So yo, what up? So we're gonna start off doing some like factoring type stuff. So that's what this is. So factors are numbers you multiply to get a product. All right. Factors are the numbers that you multiply together to get a product. For example, 2 times 5 is 10, right? So the factors would be the two numbers that you multiply to get 10, and which is 2 and 5. Another one, 1 times 10 is 10. The two factors that you use to get the product 10 is 1 and 10. A third example is 3 times 7 equals 21, right? So the factors are 3 and 7. Alright? So that's how that works. The factors are the numbers that you multiply together to get the product. That's that and that. That's that and that. That's that and that. Boom. Took these two numbers are the factors. The answer is the product. These two numbers are the factor. The answer is the product. These two numbers are the factor. The answer is the product. Alright, so we finna go over some prime numbers and composite numbers. Alright? We're finna learn the difference between prime numbers and composite numbers, alright? So the difference is here, as seen on this board. Prime numbers is defined by having only two factors. Composite numbers has more than two factors. That's the difference. Prime numbers have only two factors. Composite numbers has more than two factors. For example, if it's a prime number, again, it has two factors. 7. You can multiply 1 times 7 to get 7, right? 1 times 7 equals 7. Can you multiply anything else to get 7? Nope, you can't. So those are the only two factors it has. And because it only has two factors, that makes it a prime number. Let's look at the number 11. What can I multiply to get 11? I can multiply 1 times 11 equals 11. Boom. There's nothing else that I can multiply to get 11. And because those are the only two factors, that makes it a prime number. Remember, prime number only has two factors. Now, if it has more than two factors, that makes it a composite number. Let's look at an example. For the number 4, we can multiply 1 times 4 equals 4, right? We can also multiply 2 times 2 equals 4. Now, when I count the factors, I see 1, 2, 3, 4. I have 4 factors, all right? That makes this number 4 a composite number because it has more than 2 factors. Again, prime number, for the 7 it had 1, 2 factors. That made it prime. For the 11 it had 1, 2 factors. And because it only had 2 factors, that made it a prime number. But for composite, when I multiplied the factors together to get 4, it gave me more than 2 factors. Let's look at 12. I can multiply 1 times 12 equals 12. I can also multiply 2 times 6. That will give me 12. Is there anything else I can multiply together to get 12? Sure it is. 3 times 4. That gives me 12. Commutative property tells me I can multiply 4 times 3 or 6 times 2 or 12 times 1 to get 12. Now, as I go down this list and start with 1 times something, 2 times something, 3 times something, that's what I do. And after 3, I ask myself, does 4 times something give me 12? Now, because 4 times, I know 4 times 3 equals 12, right? But because of 4 is already on the board, 4 and 3, I don't have to rewrite it, all right? If it's already on the board, you don't have to write it a second time in terms of repeating it. So when I count my factors for the 12, I see that I have 1, 2, 3, 4, 5, 6 factors. Because I have 6 factors, that lets me know that the number 12 is a composite number and not a prime number, because prime numbers have only 2 factors. Composite numbers have more than 2. Yeah, that's how that works. Okay, so we finna practice finding factors to different numbers, all right? We want to find factors, so this is what we're going to do. I had a number 12, right? I'm going to write as many factors as I can for the number 12. I'm also going to write next to 12 as to whether this is a prime number or composite number, all right? So again, I want you to identify the number as prime or composite, and I also want you to write the amount of factors there is. You can pause this little video and do it on your own. We got the number 12, 20, 16, 17, 4, and 23. And then press start again so you can compare your answers with my answer to see if you got them right. All right? So for 12, I'm going to ask myself, we automatically know we can multiply 1 by anything to get that number. So 1 times 12 equals 12. Does 2 times something equals 12? Yes or no? Yes. 2 times 6 equals 12. Boom. Does 3 times something equal 12? Yes. 3 times 4 equals 12, right? Does 4 times something equal 12? Yes. 4 times 3. What about 5? Nope. What about 6? Yes. 6 times 2. What about 7? Nope. What about 8? Nope. 9? Nope. 10? Nope. Boom. So far I have 1, 2, 3, 4, 5, 6 factors for the number 12. Because this is more than 2 factors, I know that 12 is a composite number. Let's move on to the next one, 20. I know 1 times 20 equals 20. Does 2 times something equals 20? Yes, 2 times 10. What about 3 times something? Nope. 4 times something? Yes, 4 times 5. 5 times something? Yep, we have it already. 6 times something? Nope. 7 times something? 8 times something? 9 times something? 10 times something? Yes, 10 times 2. We got it. Now, because we see that this is more than 2 factors, we have 1, 2, 3, 4, 5, 6 factors that make this a composite number, all right? 16. We got 1 times 16, 2 times 8, 8, 9, 10, 11, 12. Yeah. 3 times something equals 16, nah. 4 times something, yeah. 4 times 4. 5 times something, nah. 6 times something, nah. So yeah, that's it. Anyway, it's more than 2 factors, so we know that's a composite. 17. 1 times 17. Can we multiply anything else to get 17? 2 times something? No. 3 times something? No. 4 times something? No. 5 times something? Nope. 6 times something? 7 times something? Nah. So, because this only has 2 factors, we know that this is 17 is a prime number because it only has 2 factors, all right? 4, we got 1 times 4, 2 times 2. Composite number because it's 4 factors. 23, 1 times 23. Can we multiply anything else to get a 23? Nah, so because this is only 2 factors, we know that this is a prime number. Just a reminder, prime numbers equals only 2. Composites equal more than 2. You can write this little thing on your paper when you're doing your work if you need a reminder. P equals only 2 factors. C equals more than 2 factors. That way when you start to count the factors, if you see it's only 2, you can know that you know it's prime. If you see it's more than 2, you know it's a composite. Take your time to copy that. Do what you do. Pause, really look at it, and take your time to understand it. So I want to talk about another thing with these numbers, all right? Since we already did the work, I'm just going to take it from here, and we're going to talk about factor pairs, all right? A pair of anything is 2 of something, all right? For example, a pair of shoes is 2 shoes. 2 socks is a pair of socks. 2 earphones is a pair of earphones, and whatever else. So when we talk about factor pairs, we're talking about the 2 numbers that came together to get whatever we was looking for. For example, If I want to know how many factor pairs there are for the number 4, I need to see how many pair of numbers that I have to multiply to get 4. How many pair of numbers? I multiply 1 times 4. That's one pair of number to get 4, right? I also multiply 2 times 2. That's another pair of numbers to get 4. I just multiplied 2 pairs of factors to get 4. So if I ask you how many factor pairs there are there for the number 4, you'll tell me that there's 2 pairs of factors. We know that there's 4 factors altogether, 1, 2, 3, 4. But when I'm looking for the pairs, I have to group it into twos. 1 pair, 2 pairs. How many pairs are there for 23? These two numbers, that's 1 pair. There's 1 factor pair for 23. For 17, there's 1 factor pair for 17. For 16, how many factor pairs are there? 1 pair, 2 pairs, 3 pairs. There's 3 pairs for the number 16. 3 factor pairs, all right? For number 20, how many factor pairs are there? 1, 2, 3. 3 factor pairs for 20, all right? For number 12, how many factor pairs are there? 1, 2, 3. There's 3 factor pairs for the number 12. All right? Now, these are small numbers, 12, 20, 16, 23, 4, and 17. These are small numbers, so we don't have a lot of numbers going all the way down the board, but you might have a big number like 80 or 90 or something, and it may be more. Never mind. Anyways, moving along. So let's talk about multiples, right? Multiples are the products you get when you multiply a certain factor by any number. What are the product? The multiples are the same thing as the products. When you multiply with the number 5 by anything, the product is the multiple, right? So for example, I have 5 times 1 equals 5, right? The product is 5, right? So 5 is a multiple of 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I just count by 5s, and whatever those products are, those are the multiples of 5, right? Same thing for 2s. Let's see. Multiples of 2s is 2, 4, 6, 8, 10, 12, 14, 16, and so on. Multiples of 3s is 3, 6, 9, 12, 15, 18, 21, 24, 27, and so forth. All right? So if you want to find the multiples, just create a list of those numbers. Yeah, that's just a list of those numbers. So the multiples of 2s, the multiples of 3s, the multiples of 5, and so forth with every other number that you do. Those are multiples. So if I ask you what is a so if I ask you is 18 a multiple of 3, you'll look at your list of 3s and see that 18 is a multiple of 3. What do I ask you? What is a multiple of both 2 and 3? If I want to know what is a multiple of both 2 and 3, I'll look and see which number is in both lines. I see there's a 6 over here and a 6 over here, so that's a multiple that 2 and 3 share. Also, I see that there's a 12 over here and a 12 over here. They both share the multiple 12. I guess that's it. Yeah, those are common multiples that they share. All right, so that's how that works. So if you want to compare two different numbers when it comes to their multiples, you want to first write the list of multiples and then look at both lists to see what they have. That's how that works. Let's do two quick little questions I put on the board right quick. So let's select all the factors of 12. We're looking for factors of 12. If I say a question like this, and I want to know the factors of 12 and I want to select it, one of the things I can do is I can do a chart. Yeah, we over there. I can do a little chart. Boom, bam, put 12. And I can start doing my little factors. 1 times 12 equals 12. 2 times 6 equals 12. 3 times 4 equals 12. 4 times 3, 5, da, 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 da. Okay, so I did my chart, so I have my factors on my 12 chart, right? So now all I have to do, if they want me to select all the factors of 12, is I have to see which of these numbers is on this list. Is a 1 on my list? Yes. So I know A would be an answer. Is there a 2 on the list? Yes. Is there a 3 on the list? Yes. What about a 12? Yes. What about a 15? No. What about a 6? Yes. So my answer will be A, B, C, D, and F. Let me just go over that one more time. The first thing I did, they asked me to select all the factors of 12. I did my 12 factor T-chart, and then I did my multiplication, and then I compared. I say, is there a 1 here? Yes. 2? Yes. 3? Yes. 12? Yes. 15? No. 6? Yes. Boom. Circle my answers. That didn't take all day. 2 steps. So let's look at the next question. They asked me which number is a composite number. I want to know which number is a composite number. Okay, so if I'm going to answer this, I need to remember and know the difference between a composite number and a prime number. My mind, now I remember the prime number is only two factors. Composite number is more than two factors. All right? So for the number 2, is it two factors or more than two factors? 1 times 2, that's all I can do. I can't do it 2 times something, so I only have two factors. That let me know that this is a prime. They're looking for composite. Let me circle composite so I don't forget. That's a prime, so that's not an answer. 3, 1 times 3, that's all. That's a prime. So that's not an answer. They're looking for composite. 16, 1 times 16, 2 times 8. Right off the back, I already know that there's more than 4 factors, so that's a composite. That's what they're looking for. So C would be an answer. 11. 1 times 11. Can I multiply anything else to get 11? I can't. So that makes that a prime number. They're not looking for prime, they're looking for composite. So my answer is 16. Which number is a composite number? It's 16. Take some time to pause and get that in your brain. Get that in. Last 2 questions. It say, which is a factor of both 20 and 16? I'm looking for a factor of both of those numbers. So, out of these answer choices, which of these numbers are a factor of both of these numbers? So this is what I'm going to have to do. T-chart for 20, T-chart for 16. All right? 1 times 20, 2 times 10, 4 times 5. Those are the factors of 20. Uh, 5 times 4, 10 times 2, 20 times 11. 1 times 16, 2 times 8, 3 times something, nope. 4 times something, yeah, 4 times 4. 5 times 5, 5 times something, nope. 6 times something, nope. So those are the factors for 16. I want to know which one of these are on both of these charts. Is there a 16 on both? Nope. There's only a 16 on one. Is there an 8 on both? Nope, there's only an 8 on one of them. Is there a 5 on both? Nope, there's a 5 only on one of them. Is there a 4 on both? Yes, there's a 4 here on the 20 chart and a 4 on the 16 chart. So this, my answer would be D, which is a factor that both 20 and 16 share. The factor that they share is 4. Again, my first step was to write a T-chart for both of the numbers 20 and 16 with all of its factors. Then I was to look at the answer choices and eliminate whichever answer that was not on both charts. 2 simple steps. Let's look at this last question right quick. I say, which number is a multiple of 3 but not a multiple of 2? Okay, charts. Actually, we're not doing a chart because they're not looking for factors. They're looking for multiples. What is a multiple of 3 but not a multiple of 2? Okay, so I'm not doing a chart looking for factors, but I will be doing charts for multiples, okay? So you either doing a chart for a T-chart for factors or you're doing a multiple list. So we're doing a list for 3 2s and a list for 3s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay? 3, 6, 9, 12, 13, 15, 16, 17, 18, that's doing 21, 22, 23, 24. I'm going to stop at 24 because that's the highest number on here. So I want to know which of these numbers is a multiple of 3, but not a multiple of 2. Let me see how that makes sense. 6 is a multiple of 3. 6 is a multiple of 3, but it's also a multiple of 2. So that's not what they're looking for. It's not 6 because it's a multiple of both 2 and 3, all right? They want a multiple of 3. It has to be on the 3's list, but it can't be on the 2's list. 12 is on the 3's list. 12 is also on the 2's list. 18 is on the 3's list. 18 is also on the 2's list. 21 is on the 3's list, but it's not on the 2's list. So D is an answer. Let me check this last one just in case. 24 is on the 3's list and is also on the 2's list. So we know that's not correct. So when they looked for a multiple for both 2's, they wanted a multiple for the 3's, but not for the 2's. So what they're saying is it has to be only on the 3's list, but it can't be on the 2's list. 6 was on both lists, 12 was on both lists, 18 was on both lists, and 24 was on both lists. 21 was the only number that was only on the 3's list. And for that reason, 21 is your answer. One of the things that I suggest that you do prior to a test, any and every test, is what we call a brain dump, in which is taking the first couple of minutes of your test and dumping as much information pertaining to your test on a blank piece of paper as possible, okay? So what you're going to do, because we're learning factors, we're going to do like the formula for prime numbers, a formula for, what the other thing called? Composite numbers, all right? We're going to write that down on a paper so we can be reminded as we do our test. We also going to do as many multiples of different numbers that we can, so that when we're looking at different numbers, we know and are looking for factors. It's easy for us to go and look at the multiple list and say, okay, boom, bam, that's what that is. So boom, that's what we're going to do. This is what my brain dump would look like. If they say, we're finna do a test on factors, okay, start the test. I'm taking 2 minutes. Prime numbers has only 2 factors. Composite numbers, more than 2 factors. What else I need to know for this test? Let me just do my multiples of 2's, 3's, 4's, 5's. 2, 1, 2, 3, 1, 2, 3, 4. I know 5's easy. Let me knock that out of the way. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I'll just stop at 50. I don't know how long and far they're going to go, but I'll stop there. 2 is easy. 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I'm going to start right there for 9. 3's. 3, 6, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. I'm going to stop right there. If you know how to count by 4's, count 4, 8, 9, 10, 11, 12. And if you get stuck and or don't know what the next number is, you can do your little 4 dots and count another 4 dots. You're at 12, 13, 14, 15, 16. So I know 16 is my next number. 17, 18, 19, 20, 24, 28, 29, 30, 31, 32. 32. So that's how I count and write my list of multiples for different numbers. Again, you can go up to 6, 7, 8. Are you going to take all day doing this? No, I suggested that you take like at least 2 minutes at the beginning of your test to do this. Or you can look in your test and see what numbers is going to be in your test. Like, for example, it might be a question that has to do with 6 timetables, or a question that has to do with 3 timetables. And because you're going to need to know your 6 and 3 timetables because a question is going to ask you something about that, you're going to want to do your multiples of 6s and 3s, all right? So something like that. So if they ask me, do a t-chart with the multiples of 5, so they ask me for 4, right? Oh, so if they ask you like 4 times 8, you know you can look on your 4 charts and count down 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So you know 4 times 8 is 32. Same thing with 3. It's 3 times 12. You'll count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know 3 times 12 is 36, and so forth. So that's what this multiples chart could be good for. Whatnot, and then also like we did earlier with comparing multiples, if they want to know what is both a multiple of 5 and a multiple of 3, we see what do the 3 chart and the 5 chart share? We see that they both share a 15 on this chart, 15 on this chart, and they also share a 30, so 15 and 30 that they share type thing. So you can utilize this chart for different things for your test. All right, so that's basically what it is when it comes to multiples and factors. Knowing that prime numbers only have 2 factors, multiples what them things called? Composite numbers will have more than 2 factors. Also, just remembering, for example, 1 times 12, 2 times 6, 3 times 4. Remembering what factor pairs are. Pairs have to do with groups of 2s, so that's 1 pair, 2 pairs, 3 pairs. All right? If we want to know what how many factors, you count in the numbers separately. So that's 1, 2, 3, 4, 5, 6. So that's 6 factors. 1, 2, 3. 3 factor pairs. 1, 2, 3, 4, 5, 6 factors, and 1, 2, 3. 3 factor pairs when it comes to the groups. So yeah, all that. If you have any questions, I am not the guy to ask.